Hi guys, and welcome to today's Year 8 video on solid and Euler's rule. Now the first thing is that's not Euler. Please don't mispronounce his name. It's weird. My surname has a Y in it and loads of people mispronounce it. It's so frustrating. Please don't. It is Euler's rule and solids, and we are going to be here dealing with this today. Thank you so much for logging in and loading up this video. Great to see you. My name is Darren, otherwise known as MaffsGuru, and I'm very much here to create all of these videos just for you. It's just me sitting in a recording studio, going slowly mad, talking to myself, but hopefully you are understanding this work. Now, if you can do me the favor, over in that corner there is a red arrow pointing to a little doohickey that says subscribe. Greatly appreciated if you could, and get 2 of your friends to do so as well. I'm trying to get to 1,000, and this is hard work because no one wants to watch maths videos. Now, by the end of this particular video, what is it I want you to know? What is a solid? And I don't mean baby food in that situation. I'm not talking about having, whole chips rather than everything liquidized. Do you remember those days? Ugh. Can we get nothing worse than just putting all the food in and just liquidizing it? Would be gross. You need to know what terms like vertex, edge, face, polyhedra or polyhedron, prisms, pyramids, and all those types of things. Know that actually for solids, there is a link between vertices, edges, and faces. Know how to use Euler's rule to find the number of vertices, faces, or edges given the other two. Now, that's what we're going to do. By the end, all going to make perfect sense. So in previous lessons, we've been looking at stuff at a Year 8 level, and we're soon going to move on in this measurement and geometry field to different and more complex work. We dealt with triangles and quadrilaterals and how to find angles. We've used that information to work out how many triangles are inside polygons to find angle sums. Now, polygons are 2-dimensional shapes, and it's important to know what 3-dimensional shapes are called, and as usual, Barry's being at it again. Let's make up a really complicated word, shall we, Barry? Yes, let's. Now, I don't know about you, but I used to watch Agents of S.H.I.E.L.D. I've lost the plot a little bit at the moment, too much else going on, but I'm sure there was a bad organization called Hydra. Well, I see that and I see Polyhedron, and I don't know why, but my brain goes that way. Anyway, what is a polyhedron? It is a closed solid with flat surfaces, vertices, and edges. Now, if you have breakfast cereal in the morning, you actually use a polyhedron. If you have anything that's box-like, or if you like Toblerone, or if you like any sort of different boxes of chocolates like Maltesers and whatever else, then basically you are already very much aware of polyhedron. So polyhedron, or polyhedra, can actually be named by their number of faces, all right? And we've had examples of this before. Now, the one that tends to throw lots of people is a 4-faced shape, all right? And believe it or not, that's a triangular-based pyramid. How do you draw one of those things? Well, here is my triangle that I draw as my base. I do a line, a dot above, and I connect to each of those corners. And believe it or not, there are actually dice out there that you can buy, 4-sided dice, and they are called tetrahedrons. A pentahedron has 5 faces. Can you think what type of shape would have 5 faces? Well, believe it or not, a square-based pyramid. Once again, drawing a 3-dimensional square-based pyramid, draw that, do a dot above it, and connect it to each of the corners, and believe it or not, you have a fairly ropey, but interestingly there, 5-sided shape. All right, all of those faces are flat, and it's really important they're flat. They can't be curved, they have to be flat. And then a hexahedron has 6 faces. That's the one that you use pretty much all the time. And so if I look at, I don't know, a cuboid, there we go. We've got 1 at the front, 1 at the back, 1 at the side, 1 at the side, 1 at the top, and 1 at the bottom. And there we go, ladies and gentlemen. Now, there are many, many more of these. And I don't think it's my job to give you a list of those. I reckon you should Google or Bing or I don't know, whatever your search engine of choice is, to look for the rest of them and actually put them in your summary book. But the most important thing to know is that they are effectively 3-dimensional shapes. Now, what on earth is a vertex, a face, and an edge? Now, this is the one that confuses people, and sadly, you've just got to learn it. There's no point turning around going, oh, I don't know this stuff, it's too hard. You have to learn it. So the first thing is a face. Well, in this situation here, our hexahedron or our cuboid has 6 faces. That's 6 of those flat things. The top, the bottom, the side, the front, and the back. They're all faces. An edge, well, pretty sure everyone in this world knows what an edge is, because most things have edges. There is an edge, but what on earth is a vertex or a vertice? Now again, vertex is the singular. It's just the one of them. But vertices is plural, and that's basically another word for corners. Yes, Barry, thanks once again. We could have had corners, couldn't we? We could have kept it at corners. We all know what a corner is, but no, you wanted a vertex. So in all of these shapes, we should be able to count vertices, faces, and edges. All right, so let's have a look at this then. Euler's law. Right, so let's go back to our idea of my triangular-based pyramid. So there is my triangular-based pyramid. So how many faces are there? 1, 2, 3, 4. Yep. How many vertices are there? 1, 2, 3, 4 again. And how many edges do we see? 1, 2, 3, 4, 5, 6. So V and F and E, or FV and E, we can write those down. So that is that one. What was my other shape? We had a square-based pyramid. All right, we can do that. Thank you very much. So if we look at the number of faces, how many do we have? Well, we knew there was 5. How many vertices are there? How many corners do we have? 1, 2, 3, 4, 5 again. Brilliant. And how many edges do we seem to have? 1, 2, 3, 4, 5, 6, 7, and we have 8 edges. What was the other one we had? Oh, cube or cuboids. Yep, thank you very much. Bang, 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 bang. So let's see. The number of faces we knew was 6. The number of vertices, 1, 2, 3, 4, 5, 6, 7, 8. And how many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we have 12. Now, believe it or not, Euler, who was this dude, actually realized there was a link for these shapes, for polyhedron. And what he found out was that the number of edges was equal to the number of faces plus the number of vertices minus 2. Let's just check that then, shall we? So for this shape number 1, let's say for our tetrahedron, so was 6 equal to 4 plus 4 minus 2. Well, 4 plus 4 is 8, minus 2 is 6. Hey, that worked. What about for shape number 2? Let's see, the number of edges was 8 is equal to the faces, which was 5, plus vertices and minus 2. Yes, 10 minus 2, that works. What about 3? Then let's just check once again. So the edges was 12, which was equal to 6, plus 8 minus 2, and that works every single time. So edges equals face plus vertices minus 2. Is there an easy way to remember this? Well, I tend to think there is, and I say that elephants are very fat and need to lose 2 kilos. Now, lots of people go, but no, hold on a moment, you've written that wrong because it was F plus V. Doesn't actually matter. We can write faces plus vertices or vertices plus faces. When we add 2 numbers together, the order doesn't actually matter. And I think it makes life a lot easier about elephants being very fat and needing to lose 2 kilos. And that's no disrespect to elephants. I'm so sorry, elephants. It's fine. Now, there we go. That actually was Euler's law. And that's what you're going to need for this whole section of work. But there's some more language that Barry obviously is trying to confuse you with. And a prism. Now, a prism is basically a polyhedra with 2 identical ends. So if we actually look at this, and one of my favorite chocolates in the world is Toblerone. Thank you very much. Toblerone actually comes in a prism. Why? Well, firstly, it's a polyhedra. So it's a shape made up of solid. It's solid, and they're all flat edges. If you look at that Toblerone packet, none of that is curved. But what we do notice is the front of the shape and the back of the shape, if we looked at it, was actually identical. Likewise with a cornflake packet, if we look at a cuboid, what do we notice? Is that a polyhedra? Yes, it is. A polyhedron? Yes, it is. But what we notice is the front of this shape and the back of the shape are identical. In that case, it's called a prism. Now, we've already dealt with pyramids. We like pyramids. There's the pyramids of Giza, and then there's the pyramids that we get to draw. Yes? So pyramids come really important in maths. Later on, you're going to be working out surface area of pyramids. You're going to be looking at volumes of pyramids. And basically, they're all formulas. Now, the great thing about maths is when you know what the formula is, you just have to be able to substitute. So you must be awesome at algebra. And whenever you do a section on algebra, make sure that you gun it. Because if you can gun algebra, the rest of maths becomes really simple. And that is actually a steadfast promise from me. You gun algebra, you understand how to simplify and rearrange and transpose and all that type of stuff, you will be a gun at mathematics. So there's a pyramid. We also knew that there was a triangular-based pyramid. And to be honest with you, I am sure there are other types of pyramids as well. But those are just examples, and they are polyhedron. Now a cube we had here. Now a cube and a cuboid, you can see the next one, are actually one and the same. All right, a cube is a special type of cuboid. Now the thing about a cube, hopefully as we are aware when we have sugar cubes, and it fascinates how they make them square, is that a cube is square. All right, so it's a cuboid where all the sides are exactly the same length. Cuboid, well, as we've just said there, a cornflake packet is an awesome example. In fact, anything in a box is a cuboid. These things here could be the same. They don't have to be the same, you know, but the lengths back would absolutely have to be the same. And so a cuboid is a six-sided, what do we call that? A hexahedron. And these are the tricks, right? So please don't get tricked. I've already told you that if anything has a curved surface, it is not a polyhedron, all right? It's no good, and it doesn't actually work with Euler's law either. So cones, cylinders, and spheres. What is a cone? Well, there is a cone. That is not a polyhedron. A cylinder, all right? Now, lots and lots of things come in terms of cylinders. While a cylinder is, in fact, a prism, it is not a polyhedron, all right? It is not solid and flat, okay, and three-dimensional. And the last one is a sphere. Anyone who tells me that a football is, I'm going to cry, right? Or repeatedly. So don't get tricked by those. Well, we're almost done, ladies and gentlemen. Let's just do one example of a question that came from Cambridge Essentials textbook series, the Year 8 textbook. Thank you so much, Cambridge, for letting me use your textbooks. Greatly appreciated. So use Euler's rule to find the number of faces on a polyhedron that has 10 edges and 6 vertices. Do you remember the rule? Yep. Elephants are very, try that one again, very fat and need to lose 2 kilos. All right. So do we know, what are we trying to do? We're trying to find the number of faces. So already they're trying to trick us. The number of faces is the thing we're going to try and find. So we're going to leave that as an F. Now again, depending on how strong your algebra is, it will depend on how easy you find this question. But it has 10 edges, so where I see E, I'm going to write a 10. It has 6 vertices, where I see a V, I'm going to write 6, and I'm going to take away 2. Now, because I know that we can move things around or what have you, I know that 6 minus 2 can be simplified. So 6 minus 2 becomes 4, and I can either do this in my head and say, what number do I add to 4 to give 10, or I can say, well, I've got a plus 4 here, that when I take it away from both sides, I get 6 is equal to F, and we normally write the letter F first, so the number of faces are equal to 6. Now, ladies and gentlemen, believe it or not, there's nothing more complicated about Euler's rule than what I've just shown you there. Just remember the formula, know the difference between a prism and a cube and a cuboid and, you know, a pyramid, and know what a polyhedron is, the difference between a polygon and a polyhedron, and you're done. Oh, and also don't forget algebra. All right, I'm done. Thank you very much for taking the time in watching this video. Over there is a little doohickey that you can click and subscribe if you would, and invite 2 of your friends to do the same. I am trying to get to 1,000 subscribers. Greatly appreciated if you can help me. Otherwise, there's a video loading below from a Year 8 series of videos. Hopefully, you'll find that one useful as well. Hope you're well. Have an awesome day. I look forward to seeing you in the next video. Okay, take care. Bye-bye.